Okay, we have here a whole bunch of random mole, meaning stoichiometry problems. This is a continuation of worksheet 8 where we did 1 through 11. Now it's time for 12 to 22. I hope you like the system we're using here. I solve the evens, you do the odds, and oftentimes the evens serve as a guide for the odds. Now this one will take a little bit of time to do because some of these problems are getting a little involved, but we're going to do them all, so just fast forward to if you need a certain question solved. Note that the answers are given to all the problems, so you'll know if you got it right. Number 12, for me, what is the total number of chlorine atoms if you have 2 grams of magnesium chloride? Well, I think I'd go, oh, it's not for me. You have to do that one. It's an even number one. I think I'd see what fraction of a mole that is, and then I'd recognize that for each mole of magnesium chloride, I have 2 moles of chlorine, and then I would go from moles of chlorine directly to atoms because the mole is just a number. Number 13 for me, what mass of oxygen is present in 10 grams of KNO3? Well, let's see. I'd have 10 grams. I'd figure out what fraction of a mole that is. And then I'd recognize that for every mole of KNO3, that 48 grams of it came from the oxygen. So there it is. So 10 grams of KNO3 is about a tenth of a mole, of which 48 grams came from oxygen, and blammo, it's 4.75 grams of oxygen are there. For you, what's the percent composition of silicon nitride? That's Si3N4. I'd figure out what the mass of a whole mole of that thing is, and then just divide it up for each one, the silicons and the nitrogens. For me, what's the percent composition of iron 2 sulfate hexahydrate? Whoa. I think that means iron, FeSO4.6H2O. You might want to turn that into, FeSO10H12. Or you could just Google it and they'll tell you that its molar mass is 260.91 grams. And let's see, percent composition. Well, 55.85 grams of that stuff came from the iron. That's just the one Fe. 160 grams, that should be an O. There's a typo there, see that? 160 grams of the 260 came from O, so the majority of it is O. 32 grams came from sulfur and 12 grams came from hydrogen. You would add all those up and get roughly 100%, and these are the percentages here. Note the typo. This should say O rather than Fe. And for you, chalcopyrite is a mineral which contains certain percentages there. And now you have to figure out the empirical formula. Aha. Well, good luck with that. But I noticed the number 17 is the same. So watch as I do this one, and it might help. Well, if I had a 100-gram sample, then I can directly convert my percents to grams. So I'll assume a 100-gram sample. 5 grams of beryllium is only 0.558 moles. And if I get the mole ratios, that's literally the ratio of atoms. So we can turn that into its empirical formula, the simplest ratio. So I write it down directly like that to remind me that I'm getting there fast, right? This is true. 10 grams is more than a third of a mole, so that's 0.371. Usually these start to show up as a 1-to-2 ratio, and they're not. But what else do we need? The silicon and the oxygen. 1.12 by the similar method and 3.35. Now what do? Divide by the little guy. Who is the littlest one? It looks like it is the 0.371. That'll automatically make AL1, and all the others will turn into hopefully some decent ratio. And that is a decent ratio. Look at that. 1.5 to 3 to 9. Double everything. That's called scaling. And there it is. BE3, AL2, Si6, O18. Looks like it can be simplified, but it can't. And that is Burl. For 18, you'll have to arrange each of these molecules for the lowest to the highest mass percent of oxygen. Boy, I wonder if there's any easier way to do this except to calculate each one out. Maybe you could just do it by inspection. I mean, look at this one. It only has 1 oxygen and 3 carbons. This one, 2 oxygens and 2 carbons. You might be able to do that some sort of fast way. Good luck. Number 19, combustion analysis problem. It's toluene, and we get 2.4 grams of it are burned, and that forms 8 grams of CO2 and 1.877 grams from H2O. We have to figure out the simplest formula for it. Well, when we burn that, it makes that CO2, and for every 8 grams of CO2, that's a certain mole of CO2. And there it is. We'll figure out how many of the grams came from carbon. 2.19 grams came from carbon. 12 grams is a mole. So we have started from 0.182 moles of carbon. And we'll write it this way to remind ourselves that we're getting there. It does not say that whether there's any oxygen or any other elements in it. I mean, I know, but we'll go ahead and work it through. 1.877 grams of water is formed, and that means that it contains 0.21 grams of hydrogen in that water. Notice that's 2.1016 for every 18 because 2/18 of it is hydrogen. And if 1 gram is a mole, and it is, that means we have 0.2. It started from 0.2 moles of hydrogen. And there's our ratio of carbon to hydrogen. Now, before we go any further, we better make sure we are accounting for all 2.4 grams of the toluene. And we are. Check it out. So no other elements are present. Now we divide by the little guy, and we get the weirdest ratio, CH to 1 to 1.143. Yuck. Shows that you really need to carry as much precision as you can when you do these things, because when you double it, you don't get a whole number. Triple it, you don't get a whole number. It's not till you scale this by 7 that the hydrogen finally goes to 8. Answer, C7H8. That's a challenging problem. Number 20 is for you. It's a similar problem. Number 21 is for me. It's another combustion analysis problem. Hey, they tell you it's a hydrocarbon, so I don't have to worry about accounting for my elements. And we're burning it 0.8 grams, and we get that much CO2 and that much H2O. Well, if we form that much CO2, let's see how much carbon it came from. 44 grams of carbon is a mole, of which 12 grams of carbon dioxide is carbon. That's 0.713 grams. And we have 0.8 grams of sample. We want the percent composition here, not the empirical formula. So of the 0.8 gram sample, 0.713 came from carbon. The rest would be your hydrogen, and we're done. And for you, they want the molecular formula of this compound. Good luck. There's the answer. Just you have to show the work how you got there. This is worksheet number 8, questions 12 through 22, random problems on the mole.